The North Atlantic in the winter of 1941 was a frozen, lightless hell. For the merchant seamen of the Allied convoys, it was a realm of perpetual dread. They called it the Black Pit, the mid-ocean gap beyond the range of protective air cover, where the only things waiting were the U-boats. Silent, ruthless, and invisible, German submarines operated with near impunity. They hunted in coordinated wolfpacks, summoned by encrypted radio signals to descend upon slow-moving convoys under the cover of darkness. The results were a slaughter. Ships laden with food, fuel, and munitions vital for Britain's survival were sent to the bottom in staggering numbers. The sea was littered with wreckage and frozen oil, the graves of thousands of sailors. In London, the situation was dire. Prime Minister Winston Churchill knew the brutal arithmetic. Britain was losing the tonnage war. Without the lifeline of North American supplies, the island nation would be starved into submission. The Battle of the Atlantic was not a sideshow, it was the decisive campaign of the war's early years. And the Allies were losing. The key to the U-boats' success was not just their torpedoes, but their secrecy. Every order, every sighting report, every wolfpack coordination was encrypted by a device the Germans believed to be unbreakable, the Enigma machine. It was a masterpiece of mechanical encryption, a portable typewriter-like box with a set of rotors and a plug board. When an operator typed a plain text message, the electrical current would travel through this labyrinth, lighting up a different letter on a lamp board with each key press. The settings for the rotors and plugs changed daily, according to a codebook, creating a possible 158 million combinations. To the German High Command, it was a black box of perfect secrecy. Intercepting the radio signals was one thing, reading them was another. The Bletchley Park codebreakers, a secret assemblage of Britain's brightest mathematicians, linguists, and chess champions, were stymied. They could hear the wolves howling, but they couldn't understand their language. They worked in frigid, makeshift huts, surrounded by piles of encrypted intercepts, trying to find a pattern in what appeared to be perfect chaos. They were fighting a ghost. A U-boat could report a convoy's position, and within hours, a dozen other submarines would converge, all while Bletchley Park remained blind. The pressure was immense. Every week, more ships sank. Every week, Britain edged closer to collapse. The codebreakers needed a miracle. They needed a flaw in the perfect machine. They needed the enemy to make a mistake. And on a cold, grey morning in May 1941, off the coast of Greenland, a mistake was made. It wasn't a grand strategic error. It was a simple, human act of maintenance on a rolling warship, in the middle of a battle. An act that would, against all odds, hand the Allies the very key to the Atlantic. The mission of HMS Bulldog and HMS Aubreytia on May 9, 1941, was routine escort duty for the westbound convoy OB-318. The air was cold, the seas heavy. For the crew, it was another tense day in the Black Pit. Then, the Aztec ping echoed through the hull of the Bulldog, a contact. It was U-110, commanded by Captain Lieutenant Fritz Julius Lemp. The same Lemp who, on the first day of the war, had sunk the passenger liner SS Athenia, an act that set the brutal tone for the naval conflict. The hunt was on. Depth charges tumbled from the stern of the Bulldog and the Aubreytia, their explosions sending concussive shocks through the water. Aboard U-110, the crew fought to evade, diving deep as the hull groaned under the pressure. But the damage was done. Critical systems were failing. Lemp made a fateful decision: surface and fight it out with the deck gun. It was a desperate gamble. As the U-boat broke the surface, it was met with a storm of shellfire from the British warships. The sub's crew scrambled onto the deck, expecting to be torn apart. But then, something unexpected happened. The British commander, Captain Joe Baker Creswell of the Bulldog, holding his fire, saw the German sailors abandoning ship. He gave a daring order: instead of sinking the crippled U-boat, they would board it. This was an almost unheard-of prize. To capture an enemy warship intact, with all its secrets, was the dream of every naval intelligence officer. A boarding party was hastily assembled, led by Sub-Lieutenant David Baum. They rowed across the choppy sea towards the seemingly abandoned U-boat, which was still drifting, its conning tower hatches open. What awaited them was a scene from a ghost story. The interior of the U-boat was dark, silent, and cold, smelling of oil, sweat, and fear. The lights were out, and seawater sloshed in the bilges. The German crew, believing their boat was sinking, had opened the vents. At any moment, the submarine could plunge to the bottom, taking the boarding party with it. Baum and his men moved through the narrow passageways, their footsteps echoing in the metallic silence. They were looking for anything: charts, codebooks, logs. And then, in the radio room, Baum saw it. A complex machine, bolted to a table, with a keyboard and a set of rotors. It was an Enigma. And next to it, in a drawer, were sheets of paper with settings tables. The crew, in their frantic evacuation, had failed to destroy it completely. The rotors were still in place. The codebooks for the current month were there for the taking. This was more than a prize, it was the Holy Grail. Baum signaled the Bulldog. The broken U-boat, its crew captured, was not sinking. It was a treasure trove afloat. Captain Baker Creswell now faced a monumental decision. They had to get this intelligence back to Britain. A tow was attempted, but the seas were too rough. The risk of losing the U-boat and its secrets was too great. The decision was made. Strip the sub of every piece of paper, every piece of equipment, and then scuttle it to hide the fact of the capture from the Germans. The operation was a race against time and the elements. As Baum's team systematically looted the U-boat of its cryptographic heart, the secret of the capture was so vital that the crew of the Bulldog was sworn to silence. The war in the Atlantic had just turned on a single, silent, and desperately close-run operation. The journey back to Scapa Flow was agonizingly slow for Captain Baker Creswell. In his cabin aboard the Bulldog sat a locked chest containing the most precious cargo of the war, the naval Enigma machine from U-110, its current rotors, and, most importantly, the codebooks for the Kriegsmarine's Heimisch, home waters, code, which included the U-boat traffic. The codebooks contained the daily settings for the Enigma's rotors, the ring settings, and the plug-board connections for the entire month of June, and beyond. This was not just a snapshot, it was the key to the entire system. If the Germans suspected the capture, they would change the codes, and the advantage would be lost in an instant. The secrecy was absolute. Even the crew of the Bulldog believed they had depth-charged the U-boat into oblivion after the crew abandoned ship. When the ship docked, a team of intelligence officers from Bletchley Park, led by the brilliant and eccentric Alan Turing, was waiting. The delivery of the materials was handled with the gravity of a state secret. The chest was transported under armed guard, not to a grand office, but to Hut 8 at Bletchley Park, a Spartan, unheated building where Turing and his team waged their intellectual war. The moment the Enigma and the codebooks arrived, the atmosphere in Hut 8 transformed. For the first time, they had a working, fully configured naval Enigma machine. They could now read the current U-boat traffic in real time. The effect was immediate and revolutionary. The chaotic, meaningless strings of letters in the intercepted signals now resolved into crisp, clear German. They could see the U-boat positions, their intended patrol areas, their fuel states, and even the personal messages between commanders. It was as if a blinding fog had lifted from the Atlantic. The intelligence, codenamed Ultra, was now flowing. But Turing and his team knew this was a temporary gift. The codebooks would expire at the end of the month. Their real task was to use this golden key to understand the inner workings of the naval Enigma so thoroughly that they could break it without the codebooks, day after day, even when the settings changed. The capture provided the cribs, the known plaintext and its encrypted counterpart, that allowed them to reverse engineer the machine's logical processes and test the complex mathematical theories they had been developing. They discovered nuances they had never known, the specific ways the German operators used the machine, the common phrases in their messages, the tiny procedural flaws that could be exploited. The U-110 capture didn't just give them a month's worth of intelligence, it gave them the foundational knowledge to build the bombs, the electromechanical computers designed by Turing to brute force the daily Enigma settings by testing thousands of rotor combinations at high speed. The broken Enigma from U-110 was the Rosetta Stone that allowed them to build the dictionary. The Germans, meanwhile, remained blissfully unaware. They assumed U-110 had been sunk with all hands and all secrets. Captain-Lieutenant Lemp, who had been captured, reportedly drowned during the rescue operation, taking the truth of the capture with him. The German Naval Command saw no need to change their codes, believing their system remained inviolate. For a few precious weeks, and then months as Bletchley's mastery grew, the Allies could see the entire German U-boat fleet laid out on their maps like pieces on a chessboard. The hunters had suddenly become the hunted. The stage was set for a dramatic reversal of fortune in the Atlantic, all because the captured materials from U-110 were a miraculous windfall, but Alan Turing knew it was a temporary one. The codebooks would expire, and the Germans would eventually change their procedures. The real, enduring victory would be to break the Enigma day after day, in perpetuity, without the aid of captured documents. This required moving from brilliant intuition to industrialized code-breaking. The tool for this was the bomb. Conceived by Turing and refined by fellow codebreaker Gordon Welchman, the bomb was not a computer in the modern sense, but an electromechanical beast designed to emulate the workings of dozens of Enigma machines simultaneously. Its purpose was brute force on an unprecedented scale, to test the millions of possible rotor settings for a given day at a speed no human team could ever match. The design was a masterpiece of logical inference. It exploited a critical flaw in German operating procedure: no letter could be encrypted as itself. This seemingly minor rule, combined with educated guesses about message content, so-called cribs, like weather reports or standard greetings, allowed the bombs to eliminate vast swathes of incorrect settings. When a potential match was found, the machine would shudder to a stop, and a WREN, Women's Royal Naval Service, operator would note the rotor settings for verification by the codebreakers in Hut 8. The intelligence from U-110 was the catalyst that made the bomb project viable. It provided the verified cribs and operational insights needed to calibrate these complex machines. Before the capture, the Bletchley team was theorizing in the dark. Afterward, they had a baseline of truth against which to test their machinery and their methods. The first bombs, christened with names like Victory and Agnes, were installed in dedicated outstations like Eastcote. They were enormous, weighing over a ton, filled with a dizzying network of spinning drums, wires, and brushes, their constant, deafening clatter a soundtrack to the secret war. They were temperamental, prone to mechanical failure, and required round-the-clock maintenance by a small army of WRENs. But when they worked, they were magical. A task that would have taken a team of mathematicians weeks could now be accomplished in hours. The breaking of the daily key became a systematic, if frantic, daily ritual. The U-110 capture had given Bletchley Park not just a key, but a blueprint. It allowed them to understand the specific vulnerabilities of the naval Enigma, which was more complex than its Army or Air Force counterparts. It used more rotors and had stricter procedures. Without the physical machine and its settings from U-110, the naval Enigma might have remained a black box. With it, Turing could engineer a key to pick its lock, day after day. The bombs became the factory that mass-produced this key. The broken Enigma from the Atlantic had, in effect, given birth to a machine designed to break all the others. The intelligence flow from Ultra was no longer a trickle from a single source, it was becoming a river, fed by the relentless, mechanical logic of Turing's invention. The Germans, still confident in their machine's invulnerability, continued to transmit, unaware that their secrets were being systematically unraveled by a room full of spinning drums and brilliant minds, all set in motion by. With the bombs now reliably cracking the daily U-boat settings, new, shadow war began in the Atlantic. The intelligence product, codenamed Ultra, was the most closely guarded secret of the war. Its very existence was on a need-to-know basis, higher than that of the atomic bomb. To protect the source, an elaborate doctrine of deception was implemented. Convoy commanders receiving ultra-derived rerouting orders were never told why. They were simply given new courses, often sending them on long, fuel-consuming detours to avoid wolfpacks whose positions were clearly marked on the maps at Bletchley Park and the Admiralty's submarine tracking room. Sometimes, when a convoy could not be rerouted, a support group of escort warships would be coincidentally directed to its vicinity, ready to ambush the ambushers. The goal was never to destroy every U-boat, it was to get the convoys through. Sinking a U-boat was a bonus, but it risked alerting the Germans that their communications were compromised. If the Germans suspected Enigma was broken, they would change the system, and the war would be plunged back into darkness. This created heart-wrenching dilemmas. There were instances where Bletchley Park decrypted orders for a U-boat to attack a specific, known convoy. To save that convoy would risk the source. Sometimes, the difficult decision was made to let the attack proceed, using ultra-intelligence only to coordinate a more effective defense and rescue operation, sacrificing a few ships to save the many and preserve the greater secret. The impact of Ultra was not in dramatic, single battles, but in the silent, cumulative drainage of German effectiveness. U-boat commanders grew frustrated. They would be directed to a patrol line, only to wait for days in an empty sea. Convoys seemed to possess an uncanny ability to slip through the gaps in the wolfpack screens. Fuel ran low, morale dipped, and tonnage sunk per U-boat at sea began a steady decline. The Allies, meanwhile, were winning the tonnage war. Shipyards in the United States were producing Liberty ships faster than U-boats could sink them. The combination of ultra-intelligence and overwhelming industrial production was a pincer movement strangling the U-boat fleet. The Germans attributed their declining success to improved Allied radar and air cover, which were indeed significant factors. But they never seriously considered that their precious Enigma had been compromised. Their faith in the machine was absolute. They believed the problem lay in Allied technology, not in their own compromised secrecy. This was the true genius of the Ultra operation, it weaponized German arrogance. The capture from U-110 had provided the initial key, but the meticulous, disciplined use of that intelligence is what turned it into a war-winning advantage. The codebreakers and intelligence officers weren't just reading messages. They were conducting a symphony of deception, guiding thousands of ships and tens of thousands of men across a deadly ocean, their movements dictated by the silent, decrypted whisper. By 1942, the German U-boat command, Befehlshaber der U-Boot, BDU, was growing uneasy. Their once devastating wolfpack tactics were yielding diminishing returns. Admiral Karl Donitz and his staff noted the Allies' seemingly prescient ability to evade their patrol lines. Suspicion fell on many factors: improved Allied Huff-Duff, high-frequency direction finding, which could triangulate their radio transmissions, the introduction of centimetric radar that could detect a submarine's conning tower in the dead of night, and the ever-increasing reach of Allied air patrols. The possibility of a code break was considered, but it was always the least likely explanation in their minds. The mathematical security of Enigma was an article of faith. To doubt it was to doubt the foundation of their entire naval strategy. Instead, they embarked on a technological arms race. They developed the Metox radar detector to warn of Allied aircraft. They added a fourth rotor to the naval Enigma in 1942, creating a new cipher, Triton, which plunged Bletchley Park into a period of darkness known as the Shark Blackout. This was a direct result of their not suspecting a capture, it was a routine security upgrade they believed would baffle any theoretical codebreaker. The blackout lasted for nearly a year and was a terrifying time for the Allies, coinciding with a massive increase in U-boat construction and a resumption of heavy losses in the Atlantic. It was a stark demonstration of how utterly dependent the Allied war effort had become on Ultra. But the break into Triton was eventually achieved, not through another capture, but through the sheer intellectual muscle and the mechanical power of the bombs, now refined and multiplied. The Germans, seeing the blackout end and losses mount again, still looked elsewhere for the leak. They suspected spies. They suspected treachery within their own ranks. They suspected everything except the machine on their own desks. This cognitive blockade was the Allies' greatest asset. The initial gift from U-110 had been so perfectly concealed that it poisoned the well of German suspicion for the rest of the war. Every security measure they implemented was a step behind, because they were fighting the wrong enemy. They were reinforcing the door while the Allies were reading their mail through a window they didn't know existed. The psychological chasm was immense. The Allied codebreakers lived in a world of absolute certainty, reading the enemy's most intimate thoughts. The German command lived in a world of mounting paranoia and confusion, watching their best-laid plans consistently fail for reasons they could not fathom. The broken Enigma had not just provided intelligence, it had induced a strategic blindness in the German high command from which they never. By mid-1943, the cumulative effect of ultra-intelligence reached its climax in a series of devastating convoy battles that broke the back of the U-boat offensive. The Allies were no longer just evading, they were hunting. The once confident wolfpacks now found themselves the prey. The turning point is often marked by the battle for convoys ONS-5 and SC-130 in May 1943. Thanks to Ultra, the Admiralty knew the precise positions of over 30 U-boats converging on these convoys. Instead of rerouting, the escorts were reinforced and prepared for a fight. What followed was a brutal, days-long engagement in foggy, treacherous seas. The escorts, guided by Huff Duff and radar, and forewarned by Ultra of the U-boat's tactics, fought with a ferocity and coordination that shocked the German commanders. U-boats were depth-charged, shelled, and rammed. Aircraft, vectored in from newly equipped escort carriers, pounced on submarines as they surfaced. In the battle for ONS-5 alone, 6 U-boats were confirmed sunk and several more damaged, for the loss of 13 merchant ships. For SC-130, the result was even more stunning, not a single merchant ship was lost, while 5 U-boats were sent to the bottom. The psychological impact on the U-boat arm was catastrophic. In the Kriegsmarine's War Diary, May 1943 was recorded as the month of the slaughter. The U-boat commanders, who had once roamed the Atlantic as masters of the deep, now spoke of a second happy time that was irrevocably over. They reported a terrifying new reality: the enemy seemed to be everywhere, knowing their every move. Morale plummeted. The loss of experienced crews became unsustainable. Admiral Donitz, with great reluctance, was forced to withdraw his packs from the main North Atlantic convoy routes. The Black Pit was closed. The lifeline from North America to Britain was now secure. This strategic victory, forced by the relentless application of Ultra, was a death knell for the German naval campaign. The Allies had achieved not just local tactical success, but a complete operational reversal. The U-boats were never again able to mount a sustained, effective threat to the transatlantic convoys. The flow of men and material could now proceed with growing confidence, paving the way for the immense build-up required for D-Day. The broken Enigma machine from U-110 had set in motion a chain of events that culminated in this decisive moment. The key to the Atlantic had not only unlocked German messages, it had unlocked the door to Europe's liberation. The silent war of ciphers and codes, the victory in the Atlantic was not won by admirals and generals alone. It was won in the dank, cramped interior of a captured U-boat by a young sub-lieutenant who kept his head under pressure. It was won in the frigid, makeshift huts of Bletchley Park by mathematicians, linguists, and crossword puzzle champions. It was won by the Wrens who tirelessly operated the clattering bombs, their fingers numb from the cold and their ears ringing from the noise. The secrecy of Ultra was so profound that these contributors lived in a world of shadows. They could not speak of their work to family or friends. They saw the tangible results of their labor, the ships that arrived safely, the battles that were won, but they could never claim any credit. For the sailors on the convoys, the sudden, seemingly miraculous improvement in their fortunes was a mystery. They attributed it to better escorts, to luck, or to divine intervention. They never knew that their safe passage was orchestrated by a secret army of codebreakers working round the clock in the English countryside. The weight of this secret was a heavy burden. For the intelligence officers, it meant making cold, calculated decisions that could condemn one convoy to save the secret and, by extension, thousands of future ships. For the codebreakers like Alan Turing, the pressure was intellectual and immense. A single day's failure to break the code could mean dozens of ships lost. The story of the broken Enigma is a testament to the power of collective, anonymous effort. It was a symphony of disparate talents, the bravery of the naval boarding party, the logical genius of Turing, the organizational skill of Welchman, the meticulous work of the cryptanalysts, and the mechanical endurance of the bomb operators. No single person could have done it. It was a triumph of system over individual, of process over inspiration. After the war, the secret was kept for decades. The capture of the Enigma machine from U-110 did more than help win a battle, it helped birth a new era. The intellectual and engineering challenges faced at Bletchley Park became the direct ancestors of the modern computer age. Alan Turing's seminal 1936 paper on a theoretical, universal machine found its first practical application in the design of the bomb and, later, the Colossus computers used to break the even more complex German Lorenz cipher. The problems of speed, memory, and programmable logic that the codebreakers wrestled with are the foundational problems of computer science. The very concept of software, of a machine whose function could be changed by its instructions, was pioneered in the huts of Bletchley. After the war, many of the key figures dispersed, taking their knowledge with them. They helped develop the first commercial computers, designed early warning systems for the Cold War, and laid the groundwork for the digital revolution that would transform the world. The need to break Enigma accelerated this technological timeline by decades. Beyond the hardware, the legacy of the Ultra operation fundamentally reshaped the world of intelligence and security. It demonstrated the decisive power of signals intelligence, SIGINT, on a strategic scale. The entire modern apparatus of agencies like GCHQ in the UK and the NSA in the USA can trace its philosophical and organizational roots back to the success of Bletchley Park. The principle of mass data collection and analysis, of finding patterns in noise, of the critical importance of code making and code breaking, was established as a cornerstone of national security. Conversely, the German failure taught a stark lesson about the danger of overconfidence in one's own security. The belief in the invulnerability of Enigma was a catastrophic blind spot. This lesson echoes today in the endless cycle of cybersecurity, where encryption standards are constantly tested and updated, and no system is ever considered permanently secure. The modern world, with its digital infrastructure, global communications, and constant cyber threats, is a world that Bletchley Park helped create. Every time a secure online transaction is made, there is an echo of the Enigma's rotors. Every time an intelligence agency analyzes vast datasets, they are using methods refined in the Battle of the Atlantic. The broken machine from a single U-boat was a key that unlocked far more than the German codes. It unlocked a new understanding of information as the ultimate weapon, and of the machine as the ultimate tool for wielding it. The war was fought with steel and fire, but it was won in no small part by logic and electricity, a victory whose reverberations we still feel in the silicon heart of every device we use today. To quantify the impact of the U-110 capture and the ultra-intelligence it spawned is to try to measure the absence of a catastrophe. Historians estimate that the war in Europe was shortened by at least 2 years, potentially saving millions of lives. The Battle of the Atlantic was the longest continuous military campaign of World War II, and its outcome was the prerequisite for every subsequent Allied offensive, from North Africa to Normandy. Without the ability to read the U-boat signals, the shipping losses in 1941 and 1942 would have been unsustainable. Britain would have been strangled, its war economy collapsing, making the build-up for D-Day an impossibility. The broken Enigma machine was not merely a lucky find, it was a causal event that altered the trajectory of the 20th century. The true brilliance, however, lay not in the capture itself, but in what the Allies did with it. They possessed the wisdom to recognize its worth, the intellectual power to exploit it, and the supreme discipline to protect the secret at all costs. This was a victory of mind over matter, of patience over brute force. The German U-boat service was one of the most elite fighting forces of the war, but its prowess was rendered null by an enemy it never saw and a vulnerability it never believed could exist. The story stands as an eternal testament to a fundamental truth, that in modern warfare, and indeed in the modern world, information is the ultimate strategic resource. The courage of the soldier on the front line is indispensable, but it is the knowledge of the enemy's intentions that allows that courage to be applied decisively. The capture of U-110 gifted the Allies that knowledge. It gave them the key to the Atlantic, and with it, the key to victory in Europe. It is a story that began with a single, simple failure to destroy a machine.